Hello everyone, welcome back to my channel. Today's video is about semiconductor and its type, and it is one of the most basic and important topic from our electronic science. So let us first know about some of the properties of semiconductor. It has its conductivity lying between insulator and conductor. We know insulator is a material which shows no conductivity. It is completely devoid of free carriers, and conductor is something which shows large amount of conductivity, like in case of metal. Forbidden band gap is in the order of 1 electron volt. Forbidden band gap is the band gap between a valence band and conduction band, and this is around 1 electron volt for a semiconductor. While in case of metals or in case of conductors, generally valence band and conduction band they overlap, and in insulator it goes up to 5 electron volt. So this shows a tendency to either behave as an insulator or as conductor accordingly, and we will see how in later. Now it belongs to fourth of periodic table. This means it has 4 valence electron. Okay, 4 valence electron means 4 electrons in outermost shell. Okay, now a semiconductor can be either in pure form, which is generally a silicon and germanium, or it can be a compound semiconductor like gallium arsenide. These compound semiconductors are formed by combining two elements from the group fourth. Now semiconductor can be divided as intrinsic type and extrinsic. Intrinsic semiconductors are generally pure semiconductors. It is also known as undoped semiconductor, pure semiconductor or undoped semiconductors. This means that they at 0 Kelvin they behave as insulator. So these are basically silicon and germanium. Okay. Now what are extrinsic semiconductor, or we call them as doped semiconductor? This means when some impurities are added to intrinsic semiconductor, then extrinsic semiconductors are formed. These are further divided into P-type and N-type. P-type semiconductors, P-type are formed when trivalent impurities are added to intrinsic semiconductor, and N-type is formed when pentavalent impurities are added to intrinsic semiconductors. Now what are these trivalent and pentavalent impurities? We will see in the next slide. So now what is intrinsic semiconductor? Intrinsic semiconductor is simply a lattice structure of silicon bonded by covalent bond. We know that any silicon has 4 electron in the outermost shell. So but we know that any element to get stable it needs 8 electrons. So in order to attain that stability, here we can see that each silicon has, say suppose this silicon, we talk about this silicon, it has 4 electron. Okay, and each here these are this single silicon atom is bonded with other silicon atom from all the 4 sides. So from each of the silicon it takes electron and complete its outermost shell and stabilize it. Similarly, this silicon also complete its outermost shell electron. In this way, intrinsic semiconductors are formed, but we can see that there are no free electrons here, so conductivity is 0. Conductivity is 0 at 0 Kelvin. But as temperature is increased, what happens? That these covalent bonds gets broken, and one electron and one hole is created. So we can see here that every time a bond is broken, then one electron and one hole is created. So from that we can conclude that number of holes equal to number of electrons in this case. But it does not attain that much of conductivity which is required for the device to, so that it can be used in any device. So generally intrinsic semiconductors are not used, but we use extrinsic semiconductor. So here we'll be talking about N-type semiconductor. So here N-type, as I already told you, that when pentavalent impurities are added to intrinsic semiconductor, then this N-type is formed. What are pentavalent impurities? Which has 5 electrons in outermost shell. So what happens? So we can see some of the example of N-type are phosphorus, arsenic, antimony, and so on. So here I have taken example of phosphorus, and this phosphorus has 5 electron in outermost shell, although 4 electron get bonded, but 1 electron is extra here. So this is a free electron. This is not contributing to the bonds here. So this is considered as free electron. So each phosphorus atom or each phosphorus impurity will add 1 electron. Okay. So in this way, if we see at the room temperature, then very less conductivity can be seen because of this one free electron. But what happens if temperature is increased? In that case, these bonds will also get broken and we get more electron in hole pair. But as we know that phosphorus is already contributing one extra electron, so number of electrons in this case will be greater than number of holes here. So we know that electrons contribute to the flow of current, so here the conductivity increase. Similarly, for p-type semiconductor, p-type we use are generally boron, aluminium. Okay, so p-type is formed when trivalent impurities is added to intrinsic semiconductor. Okay, so these are trivalent which has 3 electrons in outermost shell. So what happens now? See, the boron, know that it has 3 electrons in the outermost shell, so 3 electrons get bonded, but for in one case 1 electron is from silicon, so one hole will be here. So we can see that 3 electrons are bonded but one hole is created here. So hole is considered as a positive charge which is equal to which has equal value as electronic charge. So here also we can see that each boron is contributing to one hole. So similarly, when number of such impurities are added, then many holes will be generated. And but this is the case at lower temperature or at 0 Kelvin. But as we increase the temperature, what happens? Then these bonds, the bonds which are created, are also broken. Then in that case, more electron and hole pair will be created. But since boron is already adding one hole, so here in this case holes are more than electron here. But we know that holes generally have less mobility than electrons, so the current due to holes will be much less than the electron. So in due to that, we generally prefer n type of semiconductors. So this is a very small video regarding the semiconductor and its type. So hope you like it. Please subscribe to the channel and also like the video. Thank you and take care.